It's okay. You have two? We use two? Or? Oh, yeah. Is it on?
Hello, hello. Great. Yeah, hey, welcome everybody. Good afternoon. So, my name is Erik.
And my name is Mathias, or online Marens.
And we're both working with the Ethereum Foundation on the Solidity compiler. And we want to go through some nice features that we built recently. And so I will quickly drive you through the agenda for today. So first of all, we have some language features that we want to introduce to you, then also some compiler features. I want to briefly talk about future development of Solidity, and if there's any time, we also will have a Q&A session.
And as you can see, there's a QR code for the slides that you can use to follow on your own device, or to easier click the links that we're going to show you later.
Okay, and I think first of all, we are going to start with the language features.
Yeah, right into the new inheritance system. Though new is a bit of a stretch here. We added keywords, we added restrictions, we made it safer, more verbose, more explicit. And we're starting with the override and virtual keywords, which you probably know from other programming languages. Here you see a simple example pre-060. We simply derive 3 times from token, refundable token, and timed refundable token. It's a very simple example. We always call the base function of the previous class or contract. In the new version, this changes to look like this. So you notice the virtual keyword in the token contract. This has to be specified now, otherwise you cannot override the function anymore and you will get an error. And in the refundable token, you notice the override keyword. This is now required if you want to override a function. And as we want to override this function again, we also have to add virtual again, so it's not inherited, and you always have to specify it explicitly. And finally, in the last contract, you see we only specified override, so we don't intend to override again here. This makes overriding more safe. If the base implementation changes, you will get an error. If you would want to make sure no one overrides your function, you just don't make it virtual. All the common features you know from other programming languages, I suppose. In multiple inheritance, it also changed in a similar manner. Here you have a simple example. We show ERC77 contract, which implements 2 interfaces, ERC77 and ERC20. This changes in post-060 to this. The special thing to note here is the override keyword with the 2 contracts or interfaces that are overridden. You must specify every single interface you're overriding. And another thing to note here is the virtual is not specified in the interfaces because they're always virtual and it's basically not required. Anything else? No, this is basically this for multiple inheritance. Regarding abstract contracts, we have here a simple example with total supply missing a definition, and the deriving contract is not implementing it or overriding it. So this has various problems. As one, there is no implementation for total supply. This compiles, it will give you no error, but no code is generated for total supply, and you will get an error once you try to new the token class. In 060, we changed this, so you have to specify abstract in the contract, as you see at the top line. And this will result in the compiler telling you that token must also be abstract because the implementation is missing for total supply. You could, of course, also just implement total supply and get rid of this problem. Regarding interface inheritance, a small but really neat detail changed. Interfaces can now inherit from other interfaces. So in this example, the ERC777 is also implementing ERC20, and this can very easily be specified this way. Now we're leaving the inheritance topic and look at fallback and how we split it into fallback and receive.
Yeah, thank you, Matthias. So let's take a look at a pre-060 contract. So as you can see here, you have the fallback function, and this function is being called for a non-existing function signature or ether being received. So this transaction now is successful, and the contract keeps all the ether. So, and we decided to make the whole mechanic a little bit more explicit. So we introduced a receive function. And the receive function, so there's a new keyword, the receive keyword, and the receive function is only called whenever there's ether being sent via send or transfer. And now, after 060, this contract now reverts if a non-existing function is being called. This is the first part of the fallback and receive split. And now coming to the fallback part. So we have a proxy contract here. And this again has a fallback function. It's a pre-060 contract. And here in the fallback function, there's some inline assembly, and you would probably delegate the call to the contract itself. So again, this is also being called for both. So for non-existing function signature being found, and also if there's any ether being received. And here you would, with after 060, there's the new fallback keyword. And again, this is also being called for both, so for non-existing function signature being found, or if there's any ether received. But here, the compiler would now warn about that there's no receive function being implemented. And to avoid this warning, you could then easily implement the receive function. And as you can see here, we have a receive function, we have the fallback function, and then we have a generic function that's being called for both. And here you could do whatever you need to do there. It's worth to mention here that the payable keyword for the fallback function is optional. And to wrap up this new behavior, so receive is being executed on plain ether transfer. And fallback is being executed if there's no matching function signature or an empty data field was supplied and there's no receive function, as you have seen in the example before. Coming to the next change, read-only array length. So let's take a look at the pre-060 contract. This is a very simple example, doesn't make probably that much sense, but we have a stack and it has an internal array. And we have a constructor that you can pass the length, and a push and a pop function. And in the push and the pop function, you would increment the length and assign the value. And for pop, you would decrement the length and retrieve the value. So this contract has some issues. So first of all, the access to .length looks cheap, but deletion is quite expensive. Also, if you would pass in a very high number as the length into the constructor, this could lead to gigantic arrays, and then to overlapping storage. And making this read-only prevents this multiple access to the storage.
When we say delete, we mean if you decrease the length here by a larger number, it can be potentially very expensive, but it looks very cheap on the code.
And after 060, we made the access to .length read-only. So we altered the previous example. And instead of assigning to the length directly, you would have a loop here. And in this loop, the empty push function is being called, which has less hidden cost. And also, there are new functions, also push with the value, and the pop function, which was introduced in 050, if I remember correctly. And this contract behaves the same way as the contract before. And now I'm very excited about something that we introduced also recently is try catch. So you would probably know the construct from other programming languages. So let's have a look at the example. So first of all, we have a contract feed, and this has a function called data. This in the function body, there's a revert providing a reason string. So, and then we have a second contract called consumer. This has a feed and a rate function. And here you want to call the data function of the feed. And you would probably want to try want to catch a failure, but this was not possible before. So we introduced try catch syntax here. So here we changed the example, and in line 9 you can see there is the try statement, and you would call the feed.data function. Specifying the return type, and if everything goes well, you would just return the tuple with the value and the flag. And if not, like in this case, because it would always revert, providing the reason string, there's the catch branch with the signature like the string memory, and you could react on the revert providing a reason string. Let's change this example a little bit. So if there's no reason string being provided, or if there's a failing assertion like a division by 0 or something like that, there's another branch which allows you to access the low-level data. Sorry. And of course, you could combine both. Yeah, next one.
Function call options. You may know them as .value and .gas if you want to pass gas or way to an external function call. In this example, you see how we pass way to the the subscribe function, and 5gas. We changed the syntax for those because another feature that we introduced required also a new syntax, and these two work very well together. And this syntax is also not that nice because it looks like a function call, but it really isn't. And this is how we made it look now. It looks similar to named arguments. You specify the value and the gas in curly brackets before the call. Here again, we pass it to way and 5gas. And that's all there is to say about this feature. But going straight to the feature that prompted this change is high-level support for create2. This is how you would do it before. So you want to make an instance of product at a predictable address. So you get the code for product, you call the create function in low-level assembly, you give them 10 way, you add the code, you get the code length and your salt, which in this case is creatively called salt. You check if the creation failed or not and revert if it did. This is all nice, but it has quite some problems actually, and it's complicated to do. And yeah, the high-level support looks like this. So you use the simple new syntax with the previously introduced named arguments kind of syntax in the curly brackets. You simply specify the salt and the value, the way they want to that you want to pass. Things noteworthy here is we have now a constructor that is payable. We actually needed one before too, but the compiler couldn't type check what we did, so you would have reverted at runtime. Now this actually creates a compile time error. It's easier to pass arguments now to the constructor. And without salt, it would just be a normal create call here. Now we want to look at some miscellaneous features that we don't have time to elaborate much, but just want to mention.
So we added support for global enums and structs, so they don't need to be declared inside a contract anymore. And we also added the slice syntax for call data arrays.
We also added a new ASM statement, leave, which is the high-level equivalent of return. basically, like there's a low-level return assembly function as well, but that will leave the whole function that you're in. Leave will only leave the current UL function, UL assembly function. So that's allows you to structure your code flow more precisely when you're using inline assembly. Now, when I look a bit at a few compile features that we also added, starting with the ABI encoder version 2, we no longer consider it experimental now. You still have to activate it manually though, and no longer experimental means in this case there's no warning anymore if you use it, and there is no longer the experimental string in your bytecode. Additionally, the UL optimizer is now always on when you use the normal flag, because it's also considered non-experimental now. And
yeah, also worth to mention is that we put a lot of effort into the EWASM backend. So every Solidity construct that is compilable through UL is also now compilable to EWASM, and EWASM is this Ethereum flavored WebAssembly, which is a subset of it. And we also developed a small tool, which is called Solidity Upgrade. So just a quick background, some little background about it. So in our testing pipeline, we have some external projects like Gnosis, OpenZeppelin, and Colony so far. And we're always compiling those contracts with the recent compiler version. And of course, we needed to upgrade all those contracts to 0.6.0. And as you might have seen, all the inheritance changes might lead to a lot of work. So we wrote a small tool which is able to update contracts on a textual basis. So it's a hybrid solution. It works on libsolidity through and uses it to parse and compile the contracts, and then uses some regular expressions to replace them. And we have some documentation on the Read the Docs. And if you're interested in this tool, then feel free to check out the documentation. And also, we want to use this opportunity here to ask you if you have any 0.6.0 compilable contracts and you want us to integrate your project into our testing pipeline, then please feel free to approach us. So the future development, as we're a little bit short in time here, we just thought we want to mention the different possibilities you could use to take part in further discussions on the development. So we have a mailing list, which is a Google user group, and we're discussing language design topics there. Please feel free to check out the link and join the group and join the discussions. We are very happy to see more participation there.
And it's only for language design, not for Solidity programming questions.
Speaking about language design, so we are also very happy to announce the Solidity Summit, which will take place in Berlin at the end of April. So just go and check out the link, so you can sign up there and also send in proposals for workshops and talks. And it's a 2-day friendly size single track event with talks and workshops. And yeah, we are very happy to see a lot of people there, hopefully.
Yeah, finally, we are very approachable. You can always talk to us. You can report issues you have with the compiler on our GitHub issues page, or even feature ideas. We have a Gitter chat where we discuss our development-related things. You're always welcome to check in there, to ask about what features we plan, what if you want to contribute, what you could work on. We will help you to get started with the compiler internals, things like that. We also have Google Hangout meetings twice a week, Monday and Wednesday. You can always join in, listen in, talk if you want, ask questions, have project ideas that you want to do in the compiler, things like that. You're always welcome. And all these links are also in our documentation under Contribute, I think. And yeah, you're welcome to always visit us in any way. Finally, I want to reference some other talks that are going to happen here from our team. Chris is going to talk about metadata and source code repository on day 2. And Bagua is talking about how he's fuzzing the Solidity compiler to find bugs and make sure it's stable on day 3. Finally, if we still have time, we are open for questions and hopefully answers. Thank you.
Hello, and thank you for the presentation. I have many questions. I will just ask one, and we'll see if other people have questions. About the gas semantics for calls that you presented using curly brackets, which is the new version. If you look at EIP 150, this says that it's a maximum amount of gas, but there is no guarantee that that amount of gas will be provided if the call doesn't contain that much, and there is this 63/64 rule. So do you have mechanism written in Solidity 0.6, or should we do the correct assertion to verify that that amount of gas that we specify is in fact available to be passed to the call?
No, we don't have anything like that, so it would just revert in this case. What? Sorry?
By documentation, you then send the maximum that you can send, right? Because it's a EVM level assertion that only 36 out of 64 are sent. So it would not revert. Like we are doing it constantly in our contract. So it would not revert if you try to send more than is.
Ah, yeah, okay, yeah, true.
But I have also a question, if you have another. You said for the send and receive, this for the receiver callback, this is only called if you call it, or if you send funds via send and receive. How do you check that it is called via send and receive and not that it's just a call with empty data? Because send and receive is different than a call with empty data, right? Because of the gas limit.
Yeah. How's that checked on the compiler?
Or is there no difference? That's also fair for me.
Sorry? Yeah, so receive.
Okay.
Yeah.
Yeah, just one more. You talked about the push and pop mechanism for arrays and the fact that length is read-only. One thing that I used to do, maybe it was a bad behavior, is just overwrite length to 0 to clean up an entire array. So should I do a for loop with as many pops as element? Because this feels wrong, like to update the length one by one instead of erasing everything at once.
Yeah, that would be the solution in this case.
May I ask why setting lengths, like why changing lengths is expensive? Just out of a naive approach, I would have thought they just changed the length in the first slot of the storage or of the memory location.
It's twofold. Like deleting things is very expensive. So and just setting length from a high value to a very low value is expensive behind the scenes, but you don't see it. And we wanted to make it more explicit. So when you do a loop, it also feels more expensive now. And yeah.
So when I set the length of an array, it actually also under the hood does the loop to reset all the values? Because that was...
Yeah, it basically does that.
Okay.
Libule is definitely an open construction site, and there are still issues to be done there. I'm not sure how easy it is to get into the code base when you start with no knowledge at all of the compiler, but it's definitely something we can talk about.
Okay.
Okay, some other questions? Yep.
So first of all, thank you for adding exception handling to Solidity. It's actually really helped us. And the question I have is that for us, for our network, upgradability of contracts is really important to make it simple. And currently we're using the framework from Open Zeppelin, you probably know, to make contracts upgradable and still use the same storage. The question I have is, have you guys ever considered adding a language feature to simplify making contracts upgradable?
I wasn't part of discussions about that so far, but I think there is some talk about that, but there are also some critical voices about how exactly this is done.
Okay.
But exactly for questions like this, we have also the language design group to discuss just that.
Yeah, so maybe this question will fall under this design group. For upgradability, we usually use delegate calls. And there is mechanism in Solidity to implement calls using the low level. And now with the try catch, it's even easier to do simple low level calls and try to catch them. Do you expect to add mechanism for easily writing delegates call without reverting to assembly?
Can you repeat the last part of the question?
Will we be able soon to perform delegates calls at Solidity level without doing that in assembly?
I don't think there are plans for that just yet, but we can always talk about that.
Okay, thank you very much.
Thank you, everyone.